record this. X minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, so that's the one equation. That's if it looks like this. That's if it's what they call a horizontal hyperbola. Okay, if it looks the other way, then it's this equation. Then it's going to be y minus k squared over b squared minus x minus h squared over a squared equals 1. And that's if your I'm going to do that all day today. That's if your hyperbola looks like that. Why are there two equations with hyperbolas and not with ellipses? Because it's subtraction. Subtraction is not commutative, so you have to subtract in the right order. Whereas with the ellipses, yes, you could have two equations, but you don't need two equations because you can add in either order and be just fine. Okay, so we're taking those two equations and we're going to graph it and we're going to find all these pieces to it. Can I move on from the equations? Are you good there? Okay, here we go. You know what? I'm going to move my graph over. I always put it too far over, and then it's just not close enough. We're going to move it. Okay, what is the center of this hyperbola? -4, -1. Yes. Remember, it's always opposite of what it looks like up here, okay? I feel like that should be like second nature to you at this point. Hopefully it is. If it's not, make sure you're thinking opposite. For a hyperbola, how do you find your vertices? Is it whatever is bigger or whatever comes first? Whatever comes first, okay? So hyperbola, whatever comes first is going to be your vertices. So your vertices right now are coming from this. It's whatever comes first with a hyperbola. Okay. Can you tell me your a value right now? A is 2. This is a squared, right? 4 is a squared. Oh, goodness. There we go. So a is going to be 2. What's your b value? B is 5. Okay, so let's think about this. Maybe you want to plot your center right away. You can totally do that. You have -4, -1. Okay, that's your center. Your vertices have to come from here, we said, whatever comes first. So to find my vertices, I need to move that a value of 2 from where? 0, 0? No, from the center, right? So from this center, I'm going to go 2 to the left for a and 2 to the right for a. Okay, those are my vertices of my hyperbola. How do I get my rectangle? The y, right? How far are you going to move on your y? How far are you going to move? 5. Your b value is 5. So you're going to go up 5, 1, 2, 3, 4, 5, and put a little hash mark, and down 5, 1, 2, 3, 4, 5, and put a little hash mark. So you have your rectangle. Okay, that looks like this. And then remember, we do our asymptotes on the diagonals. And then if you want to just graph it right now, you're just following the lines of your asymptotes like this. Like that. Okay, so you can either name those vertices or you can just use your 2, right, to move from your x value. If you move 2 to the left, you'd be at -6. If you move 2 to the right, you'd be at -2. But you can also just see that in the points that you plotted. One of your vertices is -6, -1. The other one is -2, -1. Okay. Your transverse axis length. Do you remember what your transverse axis is? Distance between what? The vertices, right? This is your transverse axis. So your transverse axis length is always double your A value if it's this type of hyperbola, or you could just count it. That is 4 units, okay? So 2 times 2 or 4 would be your transverse axis length. Which foci equation do you use for a hyperbola? Do you add or subtract? You add, because you're subtracting in the equation, you're adding here. So it's c squared equals a squared plus b squared, or b squared plus a squared would be fine. We know a and b. We know a squared and b squared, right? 4 and 25. So c squared is going to be 4 plus 25. So your c squared is 29. To find our foci, we want c. So take the square root of that. Square root of 29 is not a nice number, so we're not going to actually take the square root. If we want to go rad 29 units from our center to get our foci, that's going to put us, well, let's just wait on the end one. What is your x value going to do? Which one stays put? Your x value or your y value for your foci? Your y value is going to stay the same, right? Your foci is going to be somewhere here and somewhere over here. So my y value isn't changing. My y value is the same as my center, which is a -1. What's my x value? The center x value, the -4, right? This -4. And then you need to go plus or minus your c value. So rad 29. And that will be your foci. So it feels a lot like yesterday, except you're doing it with a hyperbola now instead of an ellipse, right? Very similar. Okay. From your center, right? Remember, your foci is always going from the center to your foci c units away. So you want to go from here, c units this way, and c units that way. So you take that -4, because you can't actually add them together because it's a rad. You're just going to say -4 plus rad 29 and -4 minus rad 29, but you're not actually going to turn that into a simpler number because it'd be a decimal. We don't want decimals. So you're going c units to the left and c units to the right of that center point. So you just take your center, right? So the -4 and the -1, and we just add to the x value because we moved left and right. Okay? Okay. What do you do with a problem that looks like this? You divide everything by 36, right? You want to get it equal to 1. So divide by 36 here, divide by 36 here, divide by 36 here. So your standard form is going to be y squared over 9 minus x plus 4 squared over 36 equals 1. Okay? That's more lovely. That's what we want to work with. What's your center then? Be careful here. What is your... That's really tempting. -4, 0. Notice what happens. With an ellipse, it was always x first. Now with a hyperbola, your y can come first. So if your y comes first, that's your k value of your center. So you have to do x, which is -4, and y, which is 0. So you got to swap them, okay? So just pay attention to which one's x, which one's y. Are your vertices coming from the y squared over 9 or the x plus 4 squared over 36? In other words, from which comes first or from which is bigger with a hyperbola? Vertices come from which comes first, right? So that's going to come from this information. Okay, so let's think about this. I'm going to plot my... Whoop. Okay, so if we plot our center, that's negative 4, 0. What's your A value? A is 6, right? That comes from the 36. B is 3, okay? Your vertices come from the 3. So from your center, you're going to go up 3 for your B value. That's going to be a vertex. And down 3. 1, 2, 3. Another vertex. Okay. So again, you could name that from here, or you can name it from looking at the graph. But you've got 2 vertices now. Your vertices should be at negative 4, 3, and negative 4, negative 3. So if you wanted to, you could write that as negative 4 plus or minus 3. That would be fine. How big is your transverse axis? In other words, what's the distance between your vertices? That's 6, right? This right here is your transverse axis. That is 6, or double your B value. So 2 times 3, or 6, depending on if you're doubling or just counting. We said our A is 6. So when you draw your box in here, you're going to go 6 to the right, 1, 2, 3, 4, 5, 6, and put a little hash mark, and 6 to the left, and put a little hash mark. So here's my rectangle. And then your asymptotes. And then your graph. This one's really wide. Give you a second to get caught up on that. All right, foci equation. Are we adding or subtracting? We're adding, right? If you're subtracting in the standard equation, you're adding in the foci equation. So it's going to be this one. We know our A and B values are 9 and 36. Doesn't matter the order you put them in because it's addition. So C squared is going to equal 36 plus 9, or 9 plus 36 is fine. So C squared equals 45. And then if we simplify that, we're going to take the square root. Remember, the square root of 45, you got to put in simplest radical form. So square root of 9 times square root of 5 would be 3 rad 5. Okay, that's your C value. Think about where your C is going to make things change. Are we going to change from our, so you work from the center, right? From the center, are you changing your X value or your Y value for your foci? So center is here, right? Foci are going to be somewhere up here and somewhere down here. Not exactly there, but somewhere in that general vicinity. That's changing the Y value, right? Moving up higher and moving down lower, which is beautiful on this one because your Y value of your center is 0. So if you're going plus 3 rad 5 and minus 3 rad 5, It's just the positive and negative of those numbers, right? So your foci would be at -4 plus or minus 3 rad 5. Questions on that? All right, last problem, and then I'm going to just talk you through one last idea. Here we go. This one says write the equation for a hyperbola, so subtraction, right, with foci at 2, -3, and 2, 7, and a vertical transverse axis of 6 units. Okay. Let's think about this. I would first just plot your foci. I guess you don't have to. You don't have to graph this. It doesn't say you have to graph it. I'm going to graph it. So 2, -3. That's one focus. And 2, 7. That's your other focus. Okay. Then it says you have a vertical transverse axis of 6 units. Now, I would, if I were you, I would find your center right now. What is your center? If you're at these two numbers, 2, -3 and 2, 7. Your center is going to be still at 2, 2, 2. You're going to take the -3 plus 7 and cut it in half, right? So 4 divided by 2 is 2. So your center is at 2, 2. Okay? It says you have a vertical transverse axis of 6. Can you tell me where your vertices are going to be then? Where do you go from center? Say it again. 2, 5. Yep. You're going to go up 3 and down 3, right? If the transverse axis has to be 6, up 3, 1, 2, 3 is going to put you at 2, 5. So that's one vertex. And then down 3, 1, 2, 3 is going to put you here for your other vertex, 2, -1. Okay. So we're trying to write the equation. It's going to look something like this. We don't have our box written in, but we know this is the general shape of our hyperbola. So we're going to start with x or y. Why? Why? The question, why? Why do we start with y? Because our vertices are changing on the y, right? So you're going to start with y. So it's going to be your h and your k. So it's going to be y minus your k value. Sorry, let's write a number in. So y minus 2 squared over something minus x minus 2 squared over something equals 1, right? But this is this 2 and this is this 2. Okay. What's going to go here?
B squared.
That's your b squared. Yep. What is your b value? B is 3, right? B is from center to vertex. So b is going to be 3. So 3 squared is going to be 9. Okay. We don't know our a value. There's nothing that tells us that. But we can find our c value. What's our c value going to be? C is going to be 5, right? 1, 2, 3, 4, 5 from center to vertex. So C is 5, center to foci. So we can set this up. C squared equals a squared plus b squared, right? We're adding with an with a hyperbola. So c squared is 25. A squared we don't know, plus b squared, which is 9. So we're going to just take away that 9, and 16 is our a squared value. That goes up here, and you're done. Lots going on, huh?
How did you get the vertices in
So once they had told us the foci, right? Yeah, they told us the foci. So when they told us the foci, then what else did they tell us? Oh, the transverse axis. That's what it was. They've told us the foci, so we found the center, right? Perfectly in the middle of our foci. And then transverse axis had to be 6, so 3 and 3. Yeah. Any other questions on that one?
Where did you get the 9?
So our B value is always the center to the vertex, right here, which would be 3. So if B is 3, then our B squared would be the 9.
So we did y first because it was the vertices.
We did Y first because the vertices were on our Y, not our Y axis, but yes, changing on the Y value. Anything else?
How is a squared 16?
So C squared was 25, right?
Oh, so that, okay.
B squared was 9 because our C value was 5.
Yeah.
So then just subtract that. Anything else?
The center, 2, 2, 5.
So we had found, they gave us these 2 points. The center has to be perfectly between that. So I know my X value is going to be 2 if I'm perfectly between 2, -3 and 2, 7. The X value is not going to change. But then this is where you take, remember we were saying earlier, you take the average of your Y values. So you go -3 plus 7 and then cut that in half, and that's 2. So then your center is 2, 2. Okay. Okay, last thing. This is just a little key for you to help you remember how to tell, because not every equation is going to look exactly how we've been doing them, but they can still be those different conic sections, okay? So look at these equations. They look horrible, right? And you have to be able to identify them. Now in the homework, it's going to say identify and then find all these pieces. I don't need you to find all the pieces. You just have to identify, okay? And that's all I'll make you do on the test and moving forward. That's all you'll have to figure out is what are they. So here's how you tell, okay? If an equation only has one x squared or y squared, not both, it just has x squared or it just has y squared, that is a parabola, okay? If an equation has both of them, x squared and y squared, but the number in front is a different number, so 2x squared plus 3y squared, that's an ellipse. Remember, we're adding with an ellipse. If it's x squared minus y squared or y squared minus x squared, if you are subtracting them, it's a hyperbola every time. And then if you have x squared and y squared, so just like the ellipse, but now they're the same numbers in front. So 2x squared plus 2y squared, that's a circle. Okay, let me show you what I mean. So look here. Do you only have one x squared or y squared? No, you have both, okay? So right off the bat, parabola's out. This can't be a parabola. So we have both. Are we adding them or subtracting them? Subtracting. So as soon as you see that it's subtraction, you say, oh, that's got to be a hyperbola. Doesn't look like one, right? Looks a lot different than what we've been doing, but it's a hyperbola. Okay, look at letter B. You have x squared and y squared, so parabola's out. You are adding, so hyperbola's out, but you have different numbers, a 5 and a 2. So what is that? That's an ellipse. Okay, letter C, what is that? That's a parabola. You only have one, the y squared, right? There's no x squared, so this is a parabola. And then letter D, process of elimination. You have both, but your coefficient to both is the same, so that is a circle. Okay.